Hi, my name is Javier Robinson, and this is my project for the SEA's NASA Robotics team. Its full name is the Distance Immediate Sonic Transmitter, but I just call it the DIST or the DIST. And here on the right, there's an image of what the device looks like. Now, what the device does is it measures distance of whatever object is directly in front of it using a technique kind of like sonar, where it sends out ultrasound that our ears can't hear, and then when it echoes back off of whatever object is directly in front of it, it will calculate how long it took for the sound to return and then measure the distance. Then, based on whatever the distance it calculates, it activates a buzzer which beeps rhythmically and changes frequency based on the distance measured. So if an object is close, it will beep much faster than if the object is far away. And the purpose of the device is that it might make a useful tool for people who have impaired vision, since it allows you to measure the distance of an object in front of you using only sound and a small assembly. You don't have to use vision or touch or anything else. Also, I figure future versions of the device could also have features like measuring systems, like a numerical display for displaying the distance in numbers. So the goal with the project was to create a small device using a Python programming language and a Raspberry Pi computer that could solve somebody's problem. And my original design was simply to measure the distance to an object and then provide a numerical output. And having a rhythmic beeping to estimate the distance in front of you was just an additional feature. But then I realized that had a potential to be its own design. So that's what I did. And here is a demonstration of the device. As you can see, as I move the object closer to the device, it starts beeping faster and faster, and the device also records the distance in centimeters on the screen, but obviously you don't really need that for it to work. And as I move the object farther from the device, it starts beeping more slowly. So this device uses a Raspberry Pi computer, model 4B. It has an ultrasonic ranging module which takes care of a lot of the calculating the distance. It uses a buzzer for beeping and a lot of wiring. So for me, I think the highlight of the entire internship was probably, well, of course, other than getting to work on my own project, which was really cool, the highlight was probably the Earth and Space Science course that we took online. Pretty much everything in there I found really intriguing, from stuff like climate monitor satellites that NASA uses to phosphorus dust being blown all the way from the Sahara Desert to the Amazon forest, and getting to see a full simulation of the entire solar system and a whole bunch of other stuff. I just found it all super interesting. And as for challenges, I found the programming for my project to be really difficult. It's a lot of complications in the way, but ultimately I got it to work. And one of the things I got out of the SEA's internship is that it offered a lot of experience in space science and Python programming and physical computing, and I'm sure all of that is going to come in handy sometime later. So thanks a lot to the C's internship for all of that. And next, thanks a lot to my team mentors, Sha'Rell, Webb, and Jerald, Jolito. They helped with any problem I had with my project, and they were really supportive about it. And thanks to all of the C's series speakers, all of the stories and advice they have was really interesting. And thanks to everybody else who built this wonderful experience for all of us.